Hey, hello everyone, welcome back to my channel. Today I'm breaking down Google Cloud Reference Architecture for multi-agent AI systems, a blueprint that shows how a prompt travels from a user through a coordinator across the specialized subagents into model runtime and finally comes back as grounded, safe response. Let's dive in. So it's all start with application user, a prompt is submitted into frontend running on a cloud run. A serverless entry point that handle the traffic, authentication, latency, and even support human in the loop so people can pause, review, and correct an agent workflow when needed. And from the request, move to coordinator agent. The conductor of this entire system, its job is to interpret intent and select the right orchestration pattern and call best fit subagents. So sequential flow, a task A runs if deeper specialization is required, it calls task A subagent, and then task B produce an initial draft, a quality evaluator reviews it, and not just standard, a prompt enhancer rewrite or augment the input. This cycle repeats until the quality thresholds or iteration limits are reached. And no matter which pattern is followed, everything routes to a response generator subagent. This agents validate the structure, apply grounding checks, consolidated the final answer, and pushes it back through the coordinator and the front end. And the human in the loop option can step here as well, ensuring the quality before deliver. And modal interference is needed, then it must pass through the model armor. This is act as a security layer, filtering the risk like prompt injections, data leaks, or unsafe content. Only then it send the request or hit to the runtime, whether that's Vertex AI for your foundation models to run Gemini, or it might run to the custom cloud runs models or GKE for scalable containerized serving. The model armor enforces the security checks on both input and output and keep everything locked down. So, how the agent runtime is flexible here. Agents themselves can run into the cloud run, which is serverless, and it's going to be faster iteration, or into the Vertex AI Agent Engine for managed orchestration, or into the Kubernetes level control on GPU bounded services. This flexibilities let teams pick the right runtime per agent depending upon the workload. And the tooling with MCP, of course, agents needs tooling capabilities. Either they are interacting with the databases, APIs, or external services. That is where the model contextual protocol comes in. And MCP client talks to the MCP servers, standardizing the tool accesses. And this means you can swap the database or API without rewriting the agent logic and keeping the boundaries clean, decoupled, and auditable. And when it comes to the agent to agent communication, the inter agent interoperability matters too. Agent to agent protocol lets the agent talks across the runtimes and languages. A Python coordinator on Cloud Run can safely run Go based quality evaluator on GKE with the authentication and capabilities standardizing ones. And the important is observability and operations. End-to-end observability is built in Google Core Cloud Observability that collects the logs, matrices, and traces across the each layer. Either it's a front end, agents, tools, calling, model invocations. This data powers for debugging, auditing, and performance fine-tuning and cost optimization. And most important for a multi-agent deployment through the enterprise, it's safety, security, and governance. And when it comes to the security, it span across the flow, the kind of like service parameters, protect the sensitive project and customer own sensitive data, and cloud armor with IAP handle the edge security, and the model armor enforce the policies, contain the safety and PI data, while quality evaluators and refine the loops guarantees reliable answers. And the identity access management is enforce the least privileges, who is accessing what information, and how this entire lifecycle looks. When users submit a prompt, the front end handles the coordinator orchestrate, write path, sub-agent execute, and models calls the guarded model armor, and tools are accessed via MCP, agent talks over A2A, and response generated validate and finalize, and observability stitches it all together. This architecture ensures the reliability, security, scalability, and continuous improvement, the pillar of enterprise grade multi AI system. That is the reference blueprint for building powerful multi agent AI flow. If you are planning to scale your own system, this architecture is the gold standard. I hope this walkthrough gave you clarity. If you found it helpful, don't forget to like, subscribe, and stay tuned for more deep dive into agentic AI. Thanks for watching, and I see you in the next one.